Hey everyone, this is the Math Nexus, and today we are going to start with exercise 2.4 of O level and IGCSE additional mathematics. And the thing is, this exercise is quite a bit conceptual and it's quite interesting, also, you can say. And what it revolves around is inequalities. And the most basic form of inequalities you would normally see is something like 1 minus 2x is greater than 5, something like this. Okay, the thing is, whenever we are going to have inequalities, we are positively saying that this is not equal. Okay, it's saying it is unequal, so that's why we have put it in the form of inequalities. And the thing is, there are some rules behind solving inequalities. So basically, um, most of the steps follow the same steps of solving as if there was an equal sign in between. For example, negative 2x will become greater than 5 minus 1, which will become negative 2x is greater than 5 minus 1, which is 4. However, there's some basic changes when it comes to the negative symbol. So whenever we are going to take the symbol on the other side. For example, we want to make this positive 2x, so we are going to take this negative symbol to the other side. And what it basically does is we divide the both side by -1, both sides, so that they can be balanced. And then we cut down this, and this negative becomes 2x is -4. However, this sign is going to change. Whenever we are going to divide both sides by a negative sign, the face of the inequality will change on the other side. So it will become, instead of 2x is greater than -4, it will become 2x is lesser than -4. And that's the most basic rule and the most repeating rule which will occur throughout the whole exercise. Um, and that's basically it, how you solve it. And then of course the complexity will increase, and we can further solve this. X is um, lesser than -4 divided by 2. X is lesser than -2. Another thing is, don't confuse it by the fact that whenever we are dividing, we are going to change the sign. Whenever we are dividing by negative sign, not a negative value, negative sign, or you can say, by the way, a negative value can also change. So whenever we are dividing by a negative value on both sides, here in this case we are dividing it by both sides, so that means the side of our or the face of the inequality will change on the other side. So that's basically it. Another concept which I found really interesting in this topic is, for example, in fact, let me just take question 1a and then I will further solve it. Okay. So for question 1a, we are going to solve the inequality. So we have x plus 3, x minus 4 is greater than 0. And by the way, please do not go ahead right now. Please, first, let me explain this part as a whole, and then you can proceed on to the other questions if you want to see it. But let me explain this question first, and then you will get a a really great concept of this exercise. So what we're going to do is open this up with the FOIL method: first, outer, inner, and last. So first, where constants, x squared, outer -4x, inner positive 3x, and last 3 multiplied by 4 is 12, -12 is greater than 0. Okay. So what we are going to do next is simplify this equation up. X squared minus 4x plus 3 is going to be -x, -12 is lesser than 0. Let me just recheck before I continue. First, x squared, outer -4x, inner positive 3x, last for 3 is 12. Okay, so what we are going to do next is open this up for the sake of this question right now, please. Second. And that's it. I'm going to use my calculator for now. So that's going to give me 1, -1, and -12. So that's going to give me two values of x. X is equals to 4 or x is equals to -3. And that's where the interesting part comes in. So we have two values of x. However, this is an inequality. This is not a equality. Okay, it's not an equals to sign. We can't say x is equals to 4 and x or x equals to -3. No, it's not that. They're telling us in this equation, they're asking us solve this. And what we can see here, this is a quadratic equation. X squared minus x minus 12 is a quadratic equation. So they are saying this is a parabola. Okay, a parabola is like this, smiley face kind of thing, or you can say it could be like this. It depends on upon the coefficient of x squared. Right now it's a positive coefficient, so it's going to be this shape. I know my drawing's really rough, so please forgive me for that. So they're saying this is it, and for let me say this is on a graph, something like this. And they're saying find the values whenever this is greater than 0. Meaning what they're saying is this is our graph, and they're saying whatever value is greater than 0. So at this point, our graph is at 0. Let me use the freehand tool. So at this point, our graph is equals to 0, this one. And so on for this point, this is equals to 0. And whatever is above this point of the graph, these points, they are all greater than 0. Okay. And whatever points of these graph is less below our x-axis, they are lesser than they are lesser than 0. And that's the basic concept. I'm going to explain it. The thing is, when we are having these values, they're telling us when x is equals to 4 and x is equals to -3. So whenever we make solve an inequality, it's preferred that you make a really a mini graph, and it's not at all important for it to be accurate or something. Just make this up, mark the points -3 and 4, and say what are the points of this graph which is lesser than 0. I mean, we do know that this is the point at which the graph is at 0, and what they are asking us right now is to tell from the points which is greater than 0. So when is the graph greater than 0? We can say the points which are going up after above the x-axis. So we can say when x is lesser than -3. So we are going to move this way for us to catch these values. Okay. So we are going to say, and this way is going to be -4, -5, and so on. So we are going to say when we go at -4, we have a positive value of x, and it's the graph is greater than 0. So it's going to give us, we're going to write x is such that x is greater than, or sorry, let me see, x is lesser than -3. So we are going to say x is lesser than -3, but you can say x is greater than 4. How can we say that? Because whenever we go after 4, 5, 6, 7, whatever, we are going to get a positive value, meaning when the graph is above the x-axis and the value is greater than 0. And for the values which would be lesser than 0, it would be these points. So we would have said that x is lesser than, if we would have taken the points lesser than 0. For the points lesser than 0, we would have said it to be that x is greater than -3, meaning it would go this way, something like this. But it is lesser than 4. So it's trapped in this area, meaning the part of the graph which is lesser than 0. So right now, I hope I've explained my point clearly. So right now we can say that x is actually lesser than -3, but it is greater than +4, for which the parabola is greater than 0 or is a positive value. So that's basically what we are going to encounter throughout this chapter. And it's a really interesting fact, and I would prefer you keep in a rough paper or a rough notebook with you throughout this exercise, because it's going to help a lot. Otherwise, it's going to be a trouble. To make this without a graph, it's really hard, and I prefer if you take a graph with you, so that it's going to be easier. So for the part B, we are going to say x minus 5 multiplied by x minus 1 is lesser than equals to 0. And what they're saying in this one is to find out the points of our parabola which are lesser than 0, meaning this point, this point, the all the points on the graph which is lesser than 0, and those points would be essentially the points below the x-axis, because after the x-axis they're coming down, and these are the point, and the distance between these points we are going to tell them about it. So right now, first solve this quadratic equation. We're going to get first x squared outer negative x inner negative 5x last positive 5 is lesser than equals to 0. Again, solve this further. X squared minus 6x plus 5 is lesser than equals to 0. That's going to give us our quadratic equation, and we are going to solve it through our calculator. So 1, negative 6 and positive 5, that is equals to x is equals to, but it's not equals to, we are going to say when x equals to 0 we have 5 and positive 1 as the values. So again, draw a really mini graph. We have 2 points, in fact something like this, 1 and 5. So they're saying 1 and this is 5, and what they are asking us is to find the values for which this quadratic equation or this parabola is lesser than or equals to 0. Okay, so what we are going to say, lesser than 0, which are the points which are lesser than 0? Obviously the points below the x-axis. So when whatever points are below the x-axis are between these two, 1 and 5. So we can say that x is greater than and equals to, because they also told us the points which are equals to 0. So x is greater than and equals to 1, but it is lesser than and equals to positive 5, and that's it. That's the main concept of it. So for part C, we have x minus 3 multiplied by x plus 7. And what we are going to do here again, open and this is greater than equals to 0, meaning the part of the parabola which is above the x-axis, and which means these points of the graph. So again, what we are going to do is open this equation up first. X squared first outer plus 7x inner negative 3x, and last negative 3 multiplied by 7 is 21. Please wait a second. Yes, so we are going to continue. Negative 21 is lesser than sorry, it's greater than equals to 0. So what we are going to do is simplify this up. X squared plus 4x minus 21 is greater than equals to 0. And after we input this into the calculator, we are going to get two values. X is equals to negative 7 or 3, which means the 2 points of x on the graph, negative 7 and 3, which are intersecting with the x-axis, are positive 3 and negative 7. So again, what they are asking us are the points which for the parabola which is greater than or equals to 3. So we have to tell the points which have the positive value and which are above the x-axis. So which are the points above the x-axis? Whichever points are behind negative 7, negative 8, negative 9. These are all going to the upwards direction, something like this. Okay, so they are positive values. So we can say that x is lesser than or equals to negative 7, because they have also asked the point which is 0. Okay, so x is lesser than or equals to negative 7, but x is greater than or equals to 3, because after the point 3 we are having a positive value for our parabola, and so on and so forth. So that's it. Okay, so the thing is, the graph which is going to be made up is going to be something like this. It's going to intersect at the x-axis at the point 0 and 5. And what they have asked us is to find the values for this parabola which is lesser than 0. So obviously the values which are lesser than 0 are going to lie between the point 0 and 5. They are all between them. And after this, the graph is exiting these points and going on to a positive value. So we do not need the positive value. However, we need the negative values. So whenever the graph is below the x-axis, we are going to get the negative values. So when is it below the x-axis? It's below the x-axis when x is greater than 0, and it's below the x-axis when it is lesser than 5. Just before 5, it's exiting the x-axis. So we can say that between the point 0 and 5, we are going to get our value of x to be the value of our parabola to be negative. So that's it. For part E, we are going to say we have 2x plus 1 multiplied by x minus 4 is lesser than 0. So again, what we're going to do is first 2x squared, outer negative 4 2s are 8x, inner plus x, last negative 4 is lesser than 0. Again, simplify this up. 2x squared negative 7x minus 4 is lesser than 0. I'm going to input my values into the calculator, which is going to give me x equals to 4 or x is equals to negative 0.5 or 1 upon 2. So again, I'm going to draw a really small graph for visualization. That's going to give me negative 0.45 and this is 4. And these are the 2 points for which the graph is going below the x-axis. And what they have asked us to find the value of the parabola which is below the x-axis, meaning it is a negative value. So again, when it's a graph below the x-axis between the points negative 0.5 and 4. So we are going to say that x is, whenever x is greater than negative 0.5, is below the x-axis, but it is below the x-axis until x is lesser than 4. So that's basically it. Let me just erase this space up so that I can proceed on to the next question. We are going to say for part F, we have 3 minus x multiplied by x plus 1 is greater lesser than sorry, yeah, so it's greater than equals to 0. So first 3x, outer positive 3, inner negative x squared, last negative x is greater than equals to 0. Again, I'm going to rearrange this. Negative x squared plus 3 sorry, plus 3x, yes, plus 3 is, oh sorry, plus 3x minus x is also going to come here. Plus 3 is greater than equals to 0, and then we are going to say negative x squared plus 2x plus 3 is greater than equals to 0. And the thing is, I've discussed clearly in my previous lectures, and I emphasize a lot on it, that it's important for the coefficient of x squared to be a positive value when you are solving inequalities or equations. So it's the graph would become a sad face, something like that. But it's important that we try to make the value, make the coefficient of x squared a positive value. So what we are going to do is again take our negative as the common. So, and we are going to divide the both sides by negative. So divide this by negative 1 and divide this by negative 1, which is going to give us x squared minus 2x minus 3, and it's greater than equals to 0. However, it's not going to be greater than equals to. It's going to be lesser than equals to, I discussed in the starting of this chapter, that whenever we divide both sides by a negative sign in the inequalities, we are going to change the phase of the sign. So now we have the equation that x squared negative minus 2x minus 3 is lesser than equals to 0. And if I solve this quadratic equation in my calculator, negative 2, negative 3, we are going to get x equals to 3 and x is equals to negative 1. And what they are asking right now for the updated equation is that to find the points whenever x is or the parabola is lesser than 0, meaning it has a negative value. So negative 1 here, positive 3 here. It's going to go somewhere like here, and we have to find the set of values which is lesser than 0. And obviously the values which is lesser than 0 is below the x-axis, and it's between the points negative 1 and 3, including the points negative 1 and 3, because they have also said that it should be equals to 0. So we are going to say that x is greater than negative 1, because that it will go in this way, greater than equals to negative 1 in fact, but it is lesser than equals to negative 3, because after this point it's going to go out into the positive values, but it is lesser than equals to 3. So that's it. This is our answer for part F. And what we are going to do next is go on to part G. Okay, so for part G, we have the equation 2x plus 3 multiplied by x minus 5 is lesser than 0. Again, open this up. First, 2x squared, outer negative 10x, inner positive 3x, and last minus 15 is lesser than 0. Okay, so the thing is, what we're going to do now is make a line. Oops, really sorry. Make a line so that I can have some separation. What I'm going to do is take this 2x squared as it is. Negative 10 plus 3 is going to be negative 7x minus 15 is lesser than 0. I'm going to input my values into the calculator, which is going to give me negative 7 and negative 15. And that is equals to x equals to 5 or x equals to negative 3 upon 2, which is equals to negative 1 upon 5, 1.5. So again, draw really mini graph. Negative 1.5 and this is the 0.5. For example, this is not supposed to be accurate. So they're telling us to find the points which is lesser than 0, meaning whichever have a negative value for the parabola. So obviously the points between negative 1.5 and 5 are the points we are looking for. So we are going to say that x is greater than negative 1.5, meaning it's going in this direction, but it is greater than negative 1.5 until it passes uh, positive 5, because after positive 5 it's going to have a positive value. So it's greater than negative 1.5, but it is lesser than positive 5. So again, what we're going to say is this is the answer. I'm going to erase this for part H. Okay, for part H, what we are going to do is write down the equation first. X minus 5 whole squared is greater than equals to 0. And basically, this is a quite different question from what we have been doing till now. So the thing is, what we do basically, if you open this up, for example, a squared minus 2 multiplied by a multiplied by b plus b squared is plus 25 is greater than equals to 0. And if we simplify this, we are going to get x squared minus 10x plus 25 is greater than equals to 0. So the thing is, If I would have solved this, I would have taken the common of 25 again. So it would have given me 2 ones are 2, 2, sorry, not the commons from 2. It's going to be 5, 5s are 25, 5 ones are 5. So what it basically means is x squared minus 5x plus 25 is greater than equals to 0, and that would give me x squared, x as the common, x minus 5 again, and minus 5 as the common, x minus 5 again is greater than equals to 0. That would give me x minus 5 multiplied by x minus 5. So that essentially means that there's only one value for x from this equation, which is 5. And we could have solved this directly from the question. I did it for your easiness. However, as we know, this is x minus 5 whole squared. So we could have directly taken 5 out of this, x equals to 5. The thing is, why is this question different? Well, if we draw the graph of this, we will get something like this. And again, this is a rough approximation. It is not the perfect graph. I've not plotted the coordinates accordingly, but I've just marked only one point accurately, which is the point 5. So the thing is, now what they have asked us is that tell us the part of the graph for which this quadratic equation is greater than and equals to 0. So which is the part of the graph which is greater than equals to 0? Well, if we would have concentrated, we would have noticed that all of the graph is either greater than 0 or it's equals to 0. The point x equals to 5 is equals to 0, and the rest of the graph is greater than 0. The graph is not coming below the x-axis. That would mean that there's no negative value for the graph. And well, they have asked us the values which are positive, and we already know there's no negative values. So what we write is that negative infinity, x is greater than negative infinity, but it is lesser than positive infinity. And let me explain this. Why does this happen? So what basically negative infinity means, that the boundaries of the mathematical values, okay, the negative boundary of the mathematical value. So the lowest of the lowest value, something like negative 6 million, even lesser than that, and they are saying for those points the graph is going to be positive, because this graph is going for eternity, it's going for infinity. So it's going to continue on the positive side for infinity. It's not going to go back, because we have already known that this is a quadratic equation graph, and that comes in the form of a parabola, and there's only one curve. Okay, they're not like waves like this which are going to continue to go down and up. There's only one curve, and that's the thing. So we can say that the smallest of the smallest value we go, it's going to be positive, and the biggest of the biggest value we can think of in the mathematical world, it's going to be positive for this graph. And that's what it basically means. And again, there we are, why have we not taken 5 in consideration now? Because in between negative infinity and positive infinity, it means that there is every value possible in mathematics. So actually they also asked us that if this value is also equals to 0. So obviously we have 5 equals to 0, so we are going to, or we have already included it into this answer. So that's basically it. So we are saying that for whatever value we can think of, from negative infinity to infinity, basically means whatever value mathematics holds. So it basically is saying that whatever value there is we can think of in the mathematical world, it's going to be positive for this quadratic equation, or you can say quadratic graph. Again, another type of this question is the part I, which says x minus 3 whole squared is lesser than equals to 0. The thing is, now this is kind of different, but it's kind of same. So if I would draw a really rough curve of how would this would seem like, it would be something like this and something like this. So that's the thing. So how it's going to be different? Hmm? Okay, so if we just solve this right now, through like something like this, x squared minus 2 multiplied by a multiplied by b plus b squared is lesser than equals to 0, and that would give us x squared minus 6x plus 9 is lesser than equals to 0. So basically what's happening now, um, we would again make this quadratic equation into factorials, and that would give us x is equals to 3. So basically what it means is that there's only one point on the graph which is touching the x-axis, which is at the x value of 3. And so the thing is, what they're basically telling us, asking us actually, is tell us the values which are lesser than and equals to 0. And if we look at the graph, there is no value which is lesser than 0. And if they have only asked us the value which were lesser than 0, we would have written no possible values for this graph. However, they've also asked us the value which is equals to 0, and we can see the value which is equals to 0, meaning which is actually crossing or touching the x-axis, is the point at when x equals to 3. So we will directly write that x is equals to 3 is actually our answer, because they've asked us the value equals to 0 and we have that value which is 3. However, there is no value which is lesser than 0, so we are not going to write that. So that's basically it, and this is fulfilling our requirement for part I. So that's it for today's lecture. I'll meet you with the question 2 and onwards in my next lecture, which I'll post tomorrow or day after tomorrow. So thank you for watching.